In this PowerPoint, we will talk about circulation of the atmosphere. This first picture shows the general circulation. The circulation of the wind is driven by the rotation of the earth and the incoming energy from the sun. Wind circulates in each hemisphere in 3 distinct cells that help transport energy and heat from the equator to the poles. The winds are driven by the energy from the sun at the surface as warm air rises and cooler air sinks. The Coriolis effect is defined as how a moving object seems to veer toward the right in the northern hemisphere and the left in the southern hemisphere. This is caused by the impact of Earth's rotation on its axis and the wind moving slightly right in the northern hemisphere and slightly left in the southern hemisphere. Hot air rises because when you heat a gas, it expands. When the air expands, it becomes less dense than the air around it. The less dense hot air then floats up above the more dense air. The cooler air does the exact opposite. It will become too dense and begin to fall beneath the warmer air. Therefore, that is where we get that warm air rises and cooler air sinks. Hadley cells are the low-latitude overturning circulations that have air rising at the equator and air sinking at roughly 30 degrees latitude. They are responsible for the trade winds at the tropics and control low-latitude weather patterns. In the Ferrel cells, air flows toward the poles and east near the surface, and toward the equator and west at the higher altitudes. This is reverse movement of the Hadley cells. The polar cells are located near the Earth's poles. The cold air here falls and travels inward towards the equator. Since this air is moving toward the equator, it will mix with the Ferrel cells, causing unstable weather conditions in this area.